Okay, notes, here we go. Copy these down. Okay, so we're going to wrap it up a little bit here for, well, not really. We're going to see more things on logarithms, but so really we're just going to compare now a common logarithms or logarithms versus a logarithm or a common logarithms, we can say, versus, and now we're going to introduce this new one that's called a natural logarithm. Okay, so we're going to get to that in a bit. What I want to do first is finish up a little bit notes on logarithms. Okay, before I start natural logarithms. Okay, so what I want to review here first is something back from Algebra 2, maybe even Algebra 1, where you had these, let's say for example, you had a cubed root of x. This is a cubed root. You have a little 3 right there, or it can be a 4th root, right? And you can actually write this, you can write the cubed root of x with having an exponent. And another way to say the same thing, again, because we're dealing with bases and exponents, is this will be x, right? The base is x. And this radical with the little 3 would be your exponent. But it's not a 3, it'll be a 1/3. It'll be a 1/3. So whatever this nth root is, it'll be a fraction, not to the power of 3, not a whole number. All right, so these are saying the same thing. It's just this is in what they call radical form. And we're changing it to what? Well, remember, everything pretty much is boiling down to bases and what? This is exponents, right? Changing that radical to an exponent. So likewise, if you have a 4th root of a, right? If you have a 4th root of a, and again, we don't want to see these radicals, you can say a to the power of what? Not a to the power of 4. No, it has to be a fraction. It has to be 1/4. Okay, this would be the answer for the exponent. This would be the answer for the exponent. And then what if you have, m and it's a 5th root? Well, I think you're seeing the pattern here, right? Okay, so that would be m to the power of 1/5. Okay, it's not a whole number. It's a rational. It's a fraction, right? And I know you don't see much of cube roots or 4th roots or 5th roots. Okay, but that's the point. But the question is, what if you have just the regular normal square root? What if you have a regular square root of x? Well, I know you don't write it, but really here when you have a square root of x, it's really a 2. It's really a 2 there, but you don't write it. We don't write it. It's understood. It's the first one that we know. And it's supposed to be a 2. That number is supposed to be a 2 there that they don't write. You're supposed to just know that there's a 2 there for radicals. And why is that important? Well, when you change this to exponential form, it'll be x to the power of what? Well, that'll be 1/2, right? Okay. So just kind of knowing that, then you're going to see some problems in logarithmic form, right? And they'll have these radicals, but they'll be so easy. Something like let's say for example number 1, if they say, right, solve or evaluate, what if you have log, okay, something like log 3 And then you have like the fourth root of 3. Something like this. See, it looks kind of weird, right? But it's okay. So remember, for logarithms, it's hard to solve or evaluate when it's in this form. And I've been showing you to change it to what? Exponential form. So there's a couple of parts missing here, right? Log 3, fourth root of 3. We're going to put equals x, right? Remember, when we don't have a number and an equal sign, we're going to add that. So really, this is going to be what? Right, we write this counterclockwise. It'll be 3 to the power of x is equal to what? The fourth root of 3. And see, this is where now I'm telling you we want to just use bases and exponents. So convert this radical. Convert the radical, which is that root, the radical, right? We don't say square root because they're not square roots all the time. Convert radical to exponent. And that's what I was explaining to you over here. A root 3 is a 1/3 power. A root 4 is a 1/4 power, and so on. So this would be 3 to the power of x is equal to what? 3 to the power of, not 4, 1/4. And then you can see the answers here is what? X equals 1/4. Okay, so that's how you deal with the ones that have a radical like that. Okay, so I wanted to make sure I just talked about those because you will see those and they're not too difficult, right? Okay, next, let's talk about logarithms and kind of remember that, and then you'll see how that ties into the natural logarithm. Okay. Now, a common logarithm is actually the one you'll see here on your computer, your calculator, right? We know the common logarithms have a base of 10, right? They have a base of 10. If they don't, they'll be the problems that we've been learning how to solve. But if I have like log, here's an example. If I have log of 1,000, right? We've learned these. These are the common logarithms. Well, we know that the base is 10. When they don't write it, the base is 10. You have to know that. It's not going to write it for you. You got to remember that. They're not going to write it. But as far as for you solving this, that'll be log 10 of 1,000. Well, now I know the base is 10. Remember, we're going to put equals x. And this is the way I've been showing you. And I've been keeping this consistent because I don't want to show you different things. I want to just always have you come back to this. So this will be 10 to the power of x equals 1,000, right? And that would be 10 to the power of x equals, 1,000 is 10 to the power of what? Well, there's 3 zeros, so 10 to the power of 3, right? And again, going back to this, see, we're working with getting the same base, and once the same base is established, then you just solve that up there. Well, it's telling you what x is equal to. X is equal to 3, right? One more of these common logarithms. Okay, so what if I have log of 1 over, well, 100, just to keep it easy, right? What if they show that? Well, again, don't panic. Remember, I'm not worried about the 1 over 100. I'm worried about the fact that there's no base. Remember here, if it doesn't have a base, what's the base? Well, that's when it's a common logarithm. It has a base of 10. So that's going to be log 10 of 1 over 100. Oh, right? I know the base is 10 when that's a common logarithm. And then I can do this and solve this the way we've been learning. Log 10, 1 over 100 equals x. And that's going to be... Sorry, that's going to be log 10. Oh, I'm writing it again. Oh my God. Oh wow, that's fine. I'm writing it again, sorry. So you change it to exponential form, and that's going to be 10 to the power of x is equal to 1 over 100. See? Then this is where we go back to just working with bases and exponents, right? We're going to rewrite this 100 with a base of 10. So that's going to be 10 to the power of x is equal to 1 over 10 squared, right? 100 is 10 squared. And I know the base is 10. What do we do every time we have a 1 over something like this? We move this up. Okay, so that'll be 10 to the power of x is equal to, and when that 10 to the power of positive 2 goes up, that's going to change it to 10 to the power of what? That positive 2 will change to a negative 2. And then we come back to, again, getting the same base. Once the same bases are established, right, once you've done that, then you just got to look up here to solve. Well, the answer is looking at you right there, right? X is equal to negative 2. Okay, now let me talk about the natural logarithm. That's a common logarithms, right? You've also seen logarithms that have other bases, right? You've seen logarithms with a base of 2 or 3, right? If something other than a 10, they'll write log 2, 8, something like that. If it's a 3, okay, we've seen all those, but pretty much we've talked about and learned these. Okay, let me explain what the natural logarithm is. And if you notice again if you look at a calculator, you'll see a lot. Let me zoom in here. You have a logarithm, and then it tells you right there 10. See, it works in base 10s. And then you see that right next to it, or sometimes it's above or under or to the left or to the right, somewhere next to the log key, the logarithm key, there's a ln, which stands for, well, it's really natural logarithm, but it's like logarithm natural. I don't know why they wrote it backwards like that. Natural logarithm. And notice here it has an e instead of a 10, okay? Well, e is the base. E is the base for, e is the number for a common logarithm. Oh, I got some ink on here. Or same thing over here. Let's see. Where's my logarithm key? Here it is. Logarithm. And it has a base of 10. And somewhere right there, right under its logarithm. Can you see this? Logarithms have base 10. Natural logarithm, the base is e. Okay, so let's talk about natural logarithms. Okay, so what they did is this. This is what it is. When a logarithm has a base of 2, okay, they're going to write a 2. When a logarithm has a base of 3, okay, they're going to have a 3. And when it's a 4, and when it's a 5, and then when it's a 6, they'll write that number, right? These are nice whole numbers, right? We can go down the line, log 4, okay, blah, 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 whatever. And then eventually we get to log 10, right? We talked about the ones that have, they won't say it, right? Remember that? Log of 100, this is your common logarithm. If they don't write it, we just talked about that. It has a base of what? 10. This is your common logarithm. Right, it'll have a base of 10. Okay. When the logarithm has a base of e, I'll write it here, natural logarithm, the base is e. And if you remember from a couple of lessons ago, a couple of sections ago, when we did those problems on exponential growth and exponential decay, e is a number. E is a number on your calculator, which is approximately 2.71. Remember this, right? And it's right there, right? Right, let me try it here. E, oops. e to the power of 1 is, 2.71828. It's a set number. Just think of like pi. Pi is already like a set number. It's 3.14, blah, blah, blah. There's just so many other numbers, but e is also a number like that. It's like a constant. It's a constant, but it's irrational, right? Because these numbers are just like keep going forever and ever. But we just say like about 2.718. E is this constant. It's not like a whole number 2. Your base is not 2. Your base is not 3. Your base is not 10. When you're dealing with a logarithm, when logarithms have base e, they don't like to write logarithm base e because, usually people are looking for numbers down here. And we don't want to write. So what they write instead, when a logarithm has a base e, they just call it a natural logarithm. They call it a natural logarithm, and instead of saying log with an e, they just say natural logarithm, but it's like the L is first. So when you're just pretty much dealing with a regular logarithm, but it has a base e, they just go with this, and they call it ln. You'll see the natural log. You'll just see the ln like that. And when you see the ln like that, they're not going to write the base. See, they're not going to write the base. It's a natural logarithm. You have to know that the base is e. Okay, you're going to have to know that this base is e. All right, so let's just jump into some of these problems because they're kind of pretty easy, right? They're going to be easy, so you don't have to worry about these too much. So let's just jump into some of these natural. This is a natural logarithm. It's a regular logarithm that has the base e. The base is e, which is this 2.718, right? But instead of writing log with this, they just have a special key, right? They have the special key here on the calculator, the natural logarithm, and they just use that one. Okay, and they call it a natural logarithm. But you got to know the natural logarithm, the base is always e. The base is always e. They're not going to write it. They're not going to write it. Just like over here, let's go back to these. Remember these, the regular common? If it doesn't have a base, this one is 10. This one is 10. Okay. So the problems you're going to see are going to be so simple. They're going to be like this. I just want you to have a little bit of insight with these natural logarithms. So let's say number 1, if I put ln e to the power of 7, you're like, well, what do I do with that? Well, remember, that's just like saying, I mean, we're not gonna say, but that's just like saying log e7. But we don't use, remember, we don't use this anymore. They just write ln. But the point for you is this. All you got to do is just know that the base is e, write a e, copy this, and then we're going to treat it just like logarithms. Remember, it's missing this part, so we're going to put equals x. Yeah. You're going to put ln e7 equals x, and you know that this is the base e. Oh, okay. And then when you change this to exponential form, what is it going to say? That's going to say what? E, which is this one here, to what power gives you what? E to the 7. Well, what happens here? I know this is like 2.718 and this. See, we got the same base. Remember that concept again? If we can get the same base, which we did, here the base for natural logarithms is e. Then your job is just to solve this. Well, that's going to be easy to solve. That's going to be x is equal to 7. Okay. Hold on. Okay, let's do 2 real quick again. Number 2. What if I have ln of just e. What? Well, that would be, oh, why did I write that? I could write that, but I shouldn't. Sorry. That would be ln. The base for a natural logarithm is always a little e down there. And then you'll probably see an e there, which makes it easy. And you're supposed to put e equals x. Right? Remember that? I'm going to add the base, and I'm going to add equals x. And what's the answer for ln of e? Well, change it to exponential form, and you'll know the answer. E, this e down here, e to the power of what power gives you e? Well, and it doesn't, when anything doesn't have a power, it's a power of 1, right? So that's, got the same base. We know the answer is x equals 1. Okay, and this is going to be a little tough one, but they always show this one, so I got to show you this one. What is ln 1? And you're like, what? Okay, don't think about it too much. Let's just stick to our plan and to our routine. Wouldn't that be, remember, a logarithm, you always have to put a base. And for a natural logarithm, the base is e. E, 1, and then we write e equals x, right? This is what I've been showing you and how I've been showing you. You never work in logarithms. You never work in natural logarithms. You always change them to exponential form. So we're doing the same thing here. I'm changing this to exponential form. What is this going to say? E to what power gives me 1? This is a tricky one, right? This is a tricky one. Well, remember anything to the power of 0 is 1. Remember, anything to the power of 0 is 1. Any number to the power, even a fraction to the power of 0 is 1. Any number to the power of 0 is 1. So if you have a base and an exponent and you want the answer to be 1, what does that value of x have to be? Doesn't that have to be 0? Right? Anything to the power of 0 is 1. So here the answer for x, that would be x equals 0. Right? If we want to get that answer 1, the power, anything to the power of 0 is 1. Okay, there it is. I'll put some problems there for you to work on. This should be pretty easy though. Good luck.